Okay, so this is the third differentiation video that I've done. We're going to start getting into what the actual process is about. So this question, by the way, was taken directly from the very first question on the 2011 standard for this sort of topic. Of course, the standard's changed now, but the structure of the question I don't think is going to change that much. So they've told me a function f is given by f of x is x cubed plus 5x squared minus 2. Sweet. So if I wanted to, I could look more into that function and see what shape it was and all that sort of stuff. But the question asked me to find the gradient when the graph of f at point where x equals 3. So I basically suggested at the start of differentiation that if I differentiate this function, so f dash of x, then whatever I find is the gradient function. And if I substitute a value for x into that gradient function, it will tell me the gradient at that point. So, first off, I'm going to differentiate. So I remember that differentiation is multiply by the power, subtract 1 from the power. So if I've got x cubed, I'm going to get 3x squared plus 10x done. Now, because I want to know what the gradient is when x is 3, I'm going to substitute 3 in for x. So I've got 3 lots of 3 squared plus 10 lots of 3. Now notice how I'm putting the number in brackets each time. That's because if it was a minus number, I would need to put the brackets in to work that out. 3 squared is 9 times 3 is 27, and 10 times 3 is 30. So the gradient is 57. That's it. So differentiation is really straightforward. You've got to remember a process to turn this into that. You've got to remember some notation, and then if it asks you to find the gradient, you substitute the x number in and find out what the answer is. So x equals 3, the gradient is 57. Cool, job done.